in the Energy Transitions Commission. Early in the initial Global Energy Transitions Commission, we did some work that looked at the transition for power markets, electricity markets, and the role of flexibility, whether it is on the demand side, whether it is on power plant flexibility or on storage, the role that that would have in achieving a seamless, low-cost, and effective transition to a low-carbon energy system and electricity system. One of the things that were highlighted was the importance of looking at the specific conditions around in specific countries in terms of what are the resources available, the cost of finance, the institutions. And early on when we formed the India version of the Energy Transitions Commission, it was viewed as a very important step at the core of the ETC to understand the impact of flexibility in electricity markets on development of a low carbon economy for India. At the same time, CPI has been working on the energy systems in India and on climate change in India in general since 2013. And so we have a long history of looking into the regulatory and financing issues in India. And so this work follows on meeting two paths, which is both our India path and our energy systems path, combining those. I think that you will see in this discussion we have, first on India at large and then on Tamil Nadu, that there are some very clear messages and actions that India needs to take. And these aren't necessarily the ones that always come first to mind. The importance of really developing technologies, but also developing data systems and infrastructure that allow you to build the flexibility into the market today to meet the needs of the system 4, 5, 10 years from now is really important. So this is a call to action to begin along a number of fronts to develop the capabilities that will make India have an efficient electricity market in several years' time. And finally, before I turn this over to Udit, again, I would like to thank our sponsors, the Children's Investment Fund Foundation, Shakti Foundation, the Hewlett Foundation, as well as the Energy Transitions Commission of India for their help in this work, and Terry, of course, for their help in this work, and the aid in both convening this session, but also in rolling this work out across India and building it so it'll have the full impact that we believe it merits. With that, I'll turn it over to Udit, and again, I may be back. I will be back at the end when we come to Q&A.
Thanks, David. Thank you very much. In addition to all the people that David has already acknowledged, I would also like to thank everybody who has given us the time through interviews, many of the industry teams as well as utilities, especially on our Tamil Nadu work from Tangentco. We've got quite important inputs around different aspects of the industry. Many of you may have seen parts of this analysis of the presentation or parts of the analysis before, but we are going to present it all together today to kind of bring out the key messages as a whole. And we look forward to your questions at the end. So going straight into the presentation now. The key findings from the India perspective are increased flexibility has cost impacts, reducing the overall cost to the system. India's system flexibility needs are growing. Multiple sources are available and will be required to meet the needs. And a portfolio of options is always better than following a singular path. And integrating these diverse resources requires new types of infrastructure, incentives, markets, and investments. And the last point is where the special case study that we have done on Tamil Nadu brings out a lot more granularity than we could at the India level. So looking at looking at our work on India, I think the key aspect on starting this work was to demonstrate the feasibility and critical importance of improving electricity system flexibility to support low carbon pathways for India and to deliver all of that at a reasonable cost. Our analysis suggests that flexibility in India could reduce total system electricity supply costs by 5% on average. It is lower with flexibility, whether we look at the current trajectory, which is just projecting from the current deployment of wind and solar in the country, or we look at much more ambitious renewable energy scenarios with tags in close to the 450 gigawatt target of 2030 that has come out from the government at various points. We see that in India, flexibility needs are growing much faster than energy demand under any probable renewable energy deployment path between now and 2030. In the more ambitious high renewable energy scenario, many of the flexibility needs grow 2 to 3 times faster than electricity demand. So just on the graph here, we can see that electricity demand, even peak demand, is growing by 2.2 times, whereas daily balancing needs in the more ambitious renewable energy scenarios growing thrice that at 6.3 times. And we see that as we go towards 2030 and add a lot more renewables, more of the variability comes in from the variable renewable generation of when the wind blows, when the sun shines, and when more of the hydro resources are available to the system as well on both. This is a week in July versus on an overall year basis. In India needs more of all types of flexibility by the time we get to the mid of the decade. And that's under the high renewable energy scenario, as well as under the more muted renewable energy scenarios. Growth in reserve needs may be modest, but implementation is incomplete. Ramping needs will grow significantly, driven by high share of solar, and daily balancing needs will grow substantially by 2030 and will require new resources. Seasonal flexibility will be first in specific regions, but eventually will impact India-wide utilization patterns. So, and many of these will start showing up in the regions much faster than they will start showing up overall in India. So seasonal balancing requirements in a windy state like Tamil Nadu, or ramping requirements where solar deployment has already been high, say in a state like Karnataka. And these are the places where the regional challenges and flexibility needs have already started increasing quite more rapidly than they would at an all India level increasing. So Karnataka facing fast ramping needs due to high solar energy penetration and significant seasonal flexibility needs in Tamil Nadu. Without interstate transfers and flexibility improvements by 2030, we could see up to 15 to 20% of the renewable energy curtailed versus 6% for overall India. One measure of the flexibility need is the load factor required of thermal generation in the state. And Tamil Nadu and Karnataka both will see the utilization of their thermal portfolio go down. We see this more acutely in Tamil Nadu, where by the time we have gotten to the middle of the decade, the utilization of the thermal portfolio during certain parts of the season drops down to almost 0%. India has many potential flexibility options that can be developed in time to meet these future needs. However, most of the current flexibility comes from hydro and thermal power plants, including the ramping needs as well as the daily balancing needs that we can extract from these plants. By 2030, if properly developed, each of demand side, storage, and power plant could be contributing to India's flexibility needs, but they will need to be developed. And some of the flexibility needs match much closer to the profile of demand side and storage, like daily balancing and operating reserves for demand side versus seasonal balancing, which has more limited resources from demand, or the use of storage for seasonal, which could be extremely expensive. But each of these three resources could be developed in time to meet the growing demand needs of growing flexibility demand needs of India by 2030. Our analysis shows that demand flexibility could provide some of the lowest cost options to meet India's growing flexibility needs. However, compared to using power plant flexibility or energy storage, demand flexibility is both less developed and conceptually less well understood. However, achieving large-scale demand flexibility could be transformational for India, considering the low cost. If we look at say, the daily balancing curve at the bottom of this slide, we see that all of the resources that form the demand side response together would be quite cost effective in meeting India's overall daily balancing need by 2030, which accounts up to 870 gigawatt hours. Now, in general, there are many ways to encourage flexibility, starting with tools such as time of day pricing, real-time pricing, and how consumers respond to price signals, extending agreements, etc. But the cost involved will have to include incentives to consumers and will need to make up for the inconvenience and the cost to the consumers. We looked at the potential for demand flexibility depending on who the consumer is and what they use energy for. In general, the net economic benefit to the consumer of providing flexibility. And we have combined here the total, we looked at the total connected load expected out of different kinds of demand. And that accounts for about 600 gigawatts by the time we get to 2030. But identifying the potential of each of these resources to contribute into different kinds of flexibility gives us a range of somewhere between 40 to 180 gigawatts capable of being operated flexibility. The mid case, the 90 gigawatt, represents about 84% of the potential flexible capacity offered by coal-fired power plants in the high renewable energy scenarios, with additional end users yet to be included. Apart from after demand side, we also looked at the potential of storage across multiple, battery storage being one of those, but also options like pumped hydro. Battery storage prices are coming down quite significantly. It's expected to drop by something like 75% by the end of the decade. But even with those levels of cost reductions, batteries will remain uncompetitive with power plants. And most of the cost reductions in batteries is expected to be driven by EVs. India's own EV curve is quite debatable at this point of time, with many interpretations from different parties. But we do expect that that will still continue to drive the price of storage lower in India. If we consider not just the cost of the battery pack itself, but also additional costs such as balance of systems, foundations, installation, connections, soft costs like financing, we still expect the price for battery to be dropping to about 1/4 to about $142 per kilowatt hours by the end of the decade. In India, BOS, soft costs, etc., are typically lower, and we have considered that in our assumptions. But it'll only stay lower for India, and maybe there are additional advantages there to be harnessed. But that can only happen if substantial programs of developing and installing stationary battery systems begin, which will allow us to learn by doing. Now, even with those cost reductions, we see that batteries will remain uncompetitive with power plants and demand side with regards to flexibility requirements. So here, where we have the dotted lines, we've marked up the flexibility requirement of the respective flexibility resource requirement, and battery is outside that, even if we take away the uncertainty around the deliverability of demand flexibility. However, battery storage is much better equipped to deal with multiple sources of flexibility. For example, locating batteries behind transmission constraints can also help deal with a mix of reserves, ramping, and daily balancing all through one asset. We believe that utilization of battery for multiple services, which is stacking, can actually make storage competitive sooner and can make them relevant to relevant and available to manage grid and flexibility requirements sooner as well. Sorry. Moving on to the power plants, most of India's flexibility requirements currently are met by power plants, by hydro capacity, which is not tied down to agriculture, by hydro capacity, which is not run of the river, and by thermal power plants, both coal and the limited gas capacity that is available. And We expect that this will thermal power plants and hydropower plants will continue to play a significant role in providing flexibility to the system even towards the end of the decade. Costs of providing flexibility from thermal power plants, we need to, though there are limits to how much flexibility we can get from thermal power plants, and also the costs of the flexibility. So we have done additional analysis, which has also guided some of our more detailed market reform considerations in Tamil Nadu, where we see that some of those costs are deliverable under the are recoverable under the current schemes, under the current regulations, under the current contracts, whereas others aren't. So few changes will need to be brought into the system to be able to tap into this potential of power plants to continue providing the flexibility potential that they have. Expected coal development, especially under the high renewable scenarios, would still play a significant role in meeting seasonal needs between scheduling of maintenances across seasons, and how power plants are operated between the technical minimums and their maximum availabilities, as well as potential of gathering additional seasonal capacity from some of the retiring plants, which could be added onto the system on a seasonal capacity basis. We estimate here how much flexibility potential is available by identifying which plants could provide flexibility, adjusting these numbers over time for additions and retirements, and then adjusting again for availability, 80% for coal, 70% for gas, and including repair time, etc., and then adjusting for minimum generation. After these adjustments, power plants can provide about 107 gigawatts of flexibility to the system, of which about 20 gigawatt would require plant upgrades and investment. We think captive diesel gensets or alternative backups in the system owned by consumer will also potentially contribute significantly to meeting peak daily balancing needs, especially if adequate controls and incentives can be built in to harness their capacity at the right time. Having explored the range of flexibility options for India, it is important to consider how the resources link together to meet system requirements. The cost and the construction of the optimal portfolios will depend on the level of variable renewable energy as well as the availability of demand-side flexibility. To some degree, both of these variables can be influenced by policymakers. Our portfolios have been designed to test how each of these two variables will affect flexibility options and cost. Balanced and demand flexibility options significantly reduce carbon costs, curtailment, even at low RE ambitions. And costs of integrating renewables can be kept low by optimizing the utilization of flexibility resources to meet particular flexibility needs. For example, energy storage from batteries is most suited to daily balancing rather than meeting seasonal needs. Here we see outputs from the model of how the mix of flexibility options affects power plant operation and curtailment. If we look at the right-hand side of the graph here, where we are targeting most of our flexibility coming from coal plants or the thermal and hydropower plants alone, we see that the thermal power plants have a very strained run profile where they have lots of turning up and down during the day, and which could be a very costly dispatch pattern. Whereas if we look at a balanced portfolio of options, looking at thermal, demand side, storage, all of them together, we see a more balanced approach to how the coal plants are called upon throughout the day. Also, what we notice is a reduction in curtailment, because the black line that you can see at the top of each of these graphs is demand without any adjustment. And these blue lines represent demand after factoring in flexibility. And a lot more of the variable renewable energy, which could otherwise have been curtailed, is able to be brought in with the advantage of having access to all three kinds of flexibility resources. Our analysis, Our analysis also shows that mixed portfolio has lower system costs. In the case of the current trajectory, we noticed that the demand flexibility portfolio has the absolute lowest cost, but the balanced portfolio is close by. But the balanced portfolio is the one which gives us the maximum advantage when it comes to reducing excess energy, which reduces the need for curtailment and also maximizes the carbon benefit to the system. Similarly, even under high renewable energy, which is targeting the equivalent of 450 gigawatts of total renewable energy additions by 2030, we see that the balanced portfolio is able to give us the most optimized outputs across reducing the need for curtailment, lowest system costs, as well as carbon emissions low by as much as 12%. And one of our key conclusions here is that India can afford to integrate significantly larger amount of renewables. So we're looking at about 390 gigawatts of just wind and solar under the more ambitious high renewable energy scenario, where with flexibility, with a balanced portfolio of flexibility options, the cost to the Indian electricity system is still quite a bit lower. Sorry. Still quite a bit lower than what it would have been as when if we just follow the current trajectory with no additional flexibility. Just to point out here, the red on the top is where there is certain shortfall in energy. We have assumed the most conservative approach there, where we've assumed that if there is insufficient capacity to meet some of the peak demand points, they are met by tapping into the backup diesel genset systems. Moving on, we also pointed out earlier in the presentation that regions and states, some of the regions and states will see the flexibility requirements turning up much sooner. The fact is also that the distribution of renewable energy development and coal capacity across the country is quite varied, and that again leads to quite a varied mix of flexibility profiles, both in terms of needs as well as potential for across various states. So we looked at 4 states as a case study. Within the broader India program, where we looked at Karnataka, which is front of the queue in terms of solar deployment, Tamil Nadu, which is again one of the top 2 renewable energy states in the country with highest wind energy deployment, Uttar Pradesh, which gets majority of its capacity from coal, both in-state as well as contracted from outstate, and Bihar, which again gets most of its energy requirements met through coal capacity. And evaluating the availability of different demand side options, storage options potentially in 2030, and looking at the in-state thermal capacity, we realized that both Karnataka and Tamil Nadu, which have high renewable energy, would need more flexibility, which they could be exporting from other states, which are less strained in terms of their flexibility requirements, such as Uttar Pradesh, which could be actually utilizing its contracted capacity. With better flexibility, it would have more of that capacity to export out to states with like Karnataka and Tamil Nadu. Bihar on its own would flexibility would allow them to be able to find better better utilization of the grid and also meeting their needs more assuredly, because there are they have more of a load shedding problem today than most of the other 3 states that we looked at. And the last, but the most important in terms of how do we make all of this happen? And before we go into Tamil Nadu, where we have dug a little bit deeper into a lot of these, I think the important thing is developing and integrating a lot of these flexibility options across power plant, storage, each of the demand side options. We need to access more of data to understand, for example, on the demand side, where how the end use demand profiles are expected to develop over the next few years, and how they can be tapped into both on a large scale basis as well as on a small scale basis to be able to deliver the demand side response that we need. Or to look at storage to understand what are the nodes in the grid at the transmission level, at the distribution level, where where storage is best placed? Or can we tap into the storage that exists behind the meters, large scale, small scale, both power plants, to understand what is the cost of getting more flexibility from them on an individual plant basis? Again, we need more data on that. Additional technology is required, smart systems, smart meterings, and smart billing systems to be able to access real time the capacity that would exist either in demand side or in storage or even on power plants. Awareness about all of these opportunities is key. Again, it applies across all of the flexibility options, but the greatest amount of awareness raising potentially is required at the level of the at the level of the demand side options, especially where you have large scale consumers as well as small scale consumers who need to be targeted separately. And all of this needs to be tied together through business models and incentives that allow investors to recover their cost for the investments, whether it is about putting a storage project down or it is about making the necessary changes in a power plant if needed, or for demand flexibility for, say, an industry to be able to recover the cost of the smart systems and the smart controls that would need to be put into place to honor any contracts that they would enter into with the utility for providing flexibility services. All of this needs to be backed up by smart addition of transmission capacity so that not just electricity capacity, but also flexibility trading can be facilitated. We need more open markets around more market-based ancillary services, flexibility markets themselves, where all of these capacities can be traded, and bringing it all together, integrating it into structures such as central clearinghouse, or bringing in market setups such as aggregators, which would allow players to work together and overall helped us deliver a market design that integrates all of these options, where markets can find the most optimal options to deliver the necessary capacity as more and more demand for it rises. We'll quickly move on to Tamil Nadu now, where we've done a case study on the role of market transition and market reform in delivering high renewable capacity. We started with certain hypotheses with regards to what kind of market mechanisms or what kind of structures would be relevant to deliver the necessary flexibility capacities and its integration and the backup of the additional capacity that's and the backup of new technologies and domestic value chains that would be required to both deliver these capacities as well as underpin their cost and process development in the direction to support greater amounts of integration of both capacity and flexibility. We evaluated each of these under a series of questions, looking at what the technology options were to meet each of the requirements. What would be the cost of delivering these services? What is the value of these services compared to other options? The barriers to market development for each of these options, and market design implications for them. And how do these options relate to various development issues? How can we solve the barriers that we see? I will highlight here a couple of additional points that we have explored in more detail since we looked at our India study, which we were able to look at more granularly in Tamil Nadu. And one of the key demand side resources that we have explored in further detail in Tamil Nadu is looking at the potential of industry in demand side. And industry represents about more than a quarter of the demand in Tamil Nadu. And out of which and it's spread across a number of industries with individually their own flexible capacities. For some, it's just moving the very basic of services, efficiency in the most basic of services, like in heavy industries or in iron industry. But in others, such as textile, which composes about 25% of industrial demand, we have the highest amount of flexibility. So there is a significant amount of daily shifting capacity that could be tapped into from industrial demand itself. Industrial demand in Tamil Nadu also comes with captive generation. Large consumers with captive generation make up almost 40% of the industrial demand. And these consumers could meet over 50% of their electricity demand through self-generation. And at least some of this capacity could be tied into contracts to tap into for flexibility on a daily basis, as well as looking into it from a seasonal basis. And that brings us to how significant a role we think industrial demand could play in meeting seasonal requirements, especially in a state like Tamil Nadu, which has whose seasonality requirements are almost a third of that we observed in India. And we believe that for the right incentives at the right price points, at least certain industries could be incentivized to shift their manufacturing processes to certain other parts of the year, or to shift a majority of the manufacturing processes to certain other parts of the year, which could potentially deliver a significant amount of seasonal shifting in demand from the industrial side. Now, this obviously seems like a pipe dream if you consider it in vacuum, but we need to consider the implications for industries in terms of the total cost of the industry, which they would be able to shift as well from one part of the year to the other. This has to be balanced against stuff like storage, where more of the goods need to be stored for when the demand is higher. So this is definitely an option we think needs to be explored further to help a state like Tamil Nadu meet its seasonal requirements. What we also did was we looked at different kinds of implementation models across different kinds of flexibility services for each of the technologies. What we show here is an example from storage, where we looked at how many different places could battery energy storage be deployed in, especially considering its modular and scalable nature. And we have actively considered behind the meter storage options, both large scale and small scale, tapping into the backups that exist at the industrial level as well as at the retail and domestic level. System aggregators being able to tap into large parts of that. ESCO models could help us tap into that. And obviously the most obvious placement of batteries in a lot of ways is at the substation and the wholesale level, allowing for transmission and distribution deferral. And the one that has been discussed at long length and also in recent reports, where we have looked at co-located storage with renewable, where the nature of renewable energy itself could be shifted. Each of those have their own challenges and their own opportunities in terms of the activities that they could be utilized for, but also their ability for stacking and hence the cost at which they can be brought into the system. So having looked at each of the three flexibility opportunities for Tamil Nadu, demand, storage, power plant, and what works on different metrics, we looked at how all of these could be brought together. And as we had seen in India, we see that across each of the renewable energy scenarios, the portfolio options, bringing together the power plant, the storage, and the demand side options, gives us the most significant amount of advantage when it comes to reducing the need for curtailment in the form of reducing excess energy or having or the impact on CO2 reduction in the system. And it is almost the most optimal system cost output as well, the cheapest system cost output, obviously being demand flexibility. In Tamil Nadu, what we also set out to explore, looking at the significant amount of additional energy being generated by the high renewable energy scenarios, the current policy scenario, the high renewable energy scenario, was to see if we could make some dent in the coal portfolio pipeline that the state has. Now, Tamil Nadu is expected to add gross over about 10 gigawatt of thermal capacity by 2030 across coal and gas, out of which and a net of about 7 gigawatts, because it's a large amount of capacity is also coming up for retirement during the decade. Out of that 7 gigawatt or so, 3.4 gigawatts is already under construction. So we looked at the remaining 4.8 gigawatt of coal pipeline to see what could or could not be done with that. And we realized that, especially under the more ambitious scenarios, such as the high renewable energy scenario, we could effectively get rid of the entire coal pipeline of 4.8 gigawatts by 2030 and still be able to meet the needs of the state. So, sorry. And we are able to still do that at cost advantages to the system. So if we compare that with what we saw in India, we see that the existing flexibility under the current trajectory scenario, we have significant advantage to existing flexibility if we are able to tap into a mixture of both power plants, demand side, as well as storage flexibility. The starting point in terms of the system costs is slightly higher in Tamil Nadu than it was in India. And the advantages of flexibility are much higher because certain flexibility requirements have already started growing in Tamil Nadu, especially seasonal flexibility. And we see that these advantages, and most of the advantages, in fact, the price doesn't increase very much, even for when we target much higher renewable energy scenarios. And by also giving up some of the coal pipeline that is being considered at this point of time. So we think that there is a significant advantage that we can bring in, again, from flexibility to Tamil Nadu. And for most of our analysis, we had to consider Tamil Nadu as a self-contained system to remove impact of any external factors in terms of how the system, the variability of certain external factors. So when we removed that and looked at an integrated Tamil Nadu system, which could by its deficit capacity from the exchange, we saw that we already start with an advantage of roughly around 6% into a perfectly integrated India market. That doesn't fully consider also the options of the existence of a flexibility market. So we think we could get certain additional advantages from there, both in terms of costs as well as savings in systems cost. Now, the next thing that we will spend time on Tamil Nadu is to look at how all of these flexibility options can actually be delivered. So focusing a bit more on the barriers and market reform solutions to many of these barriers across the resources. So we looked at demand flexibility, where again, we came across the challenge of lack of data by end use, by consumer segment type, the extremely fragmented nature of the market, lack of market signals around deployment of any technology or any CapEx related to demand flexibility. And we think some of the key immediate steps that Tamil Nadu could be taking is looking at agriculture pumping, feeder separation versus incentives, because Tamil Nadu is one of the states which hasn't looked at feeder separation till now. Potentially looking at a data mission to tap into regular and systemic collection of data to then be able to target end users, develop consumer awareness, expand energy suppliers remit and build a competitive market around that, create and negotiate seasonal and daily load shifting contracts with industry, similarly contracts on daily shifting with commercial cooling load, and building additional awareness around industrial consumers, and widespread information through influencers. Similarly, we looked at what could be done around what the challenges are around the power plants. And one of the costs of flexibility is not the same across all coal plants, and it needs to be tested for each of them to be able to participate. Thermal power plants are incentivized today for availability instead of flexibility, and there are lack of routes to the market for cost recovery of flexibility. Hydropower plants, flexible capacity are all limited by priority claim from agriculture and water flow requirements. So some of the key steps that we see important for the state would be looking at pilot programs to see if power plants can be operated more seasonally, what cost recovery they would require, lower minimum generation to improve ramping and shifting across existing and new plants, and enabling to shifting. In addition, something that we also need to look at how the existing contracts and regulations can be amended to both allow flexible operation of power plants and recovery of those costs and trading of those flexible capacities, shifting and also shifting existing, at least some of the existing coal to seasonal resources, change in state grid regulations, tariff regulations, etc. that would be required. Similarly, from storage, lack of data, characterization of where the biggest grid constraints are, lack of market signals are currently prohibiting the fast development of programs around storage. So we suggest pilot programs around that, exploring how developing fostering of storage can happen, storage and the manufacturing of storage can happen in Tamil Nadu, and direct contracting with third party to set the market benchmarks and to send price signals. Collating it all, we have 3 immediate targets that we think Tamil Nadu could be targeting, which is enhancing flexibility from coal-fired generation by targeting lower technical minimums, especially from new and retrofitted plants, targeting seasonal use of older plants, and all of this needs to be encompassed by regulatory and contractual upgrades. Accessing agricultural flexibility, those plants that do not go under KUSUM to solar pumps can be transferred onto separate feeders and can be available for flexibility. Procuring grid level storage through understanding the nodes for deployment, where the maximum amount of grid congestions are, and data collection by feeders to systematically identify and deploy future storage. We also believe that there are steps that can be taken now to deliver higher flexible capacity in the medium to long run. So for industrial demand flexibility and their captive generators running pilots to access both the daily and the seasonal flexibility capacities, and to set the parameters for that, identify what the costs of that will be. Initially, these could be targeted through direct contracts. Procuring behind the meter large scale storage capacity, again, could be done through direct contracts in the beginning, incentives to access large scale capacities, and overall incentivization to transition in the longer run these large scale backup capacities from diesel gensets to battery storage. And eventually, all of this needs to be brought together by market design that integrates the incentives. And we think under that, Tamil Nadu needs to develop a kind of data mission for itself, as does India, incentives to encourage greater flexibility from coal plants, development of pricing structures and incentives to target participation of behind the meter captive generation and backup, developing nodal cost assessments and evolution of the current ancillary services market, and additional incentives and mechanisms such as capacity market mechanism. In terms of presentation, that actually covers everything that we wanted to share with you about both the report that is being launched as well as the additional additive work that we think has value-added work that we think we've done in Tamil Nadu. Now we will open for question and answers if there are any.
Yeah.
So I will hand over to Felicity for a bit.
Just very briefly, yes, we've had some very interesting questions come in, both via the chat, which is fine, and the Q&A. If you would like to ask a question verbally, I can unmute you if you'd rather do that than write your question. However, we'll probably deal with the questions that we have first here. Perhaps the first few in the Q&A box that have come through. One from Yashraj Kaitan, which I think is a very good question about demand flexibility. He says, to the best of my knowledge, India doesn't currently have a demand response incentive mechanism to drive flexibility options in a commercial manner. Is there a concrete policy roadmap being suggested in this paper, which also outlines the benefits that this policy would create in monetary terms for customers, generators and discoms? And before we farm this question out to the best a person to respond to it, that's either David or Uditanshu. I should also say that that we have Himanshu Baghel, CPI Energy Finance analyst based in Delhi, joining us for the Q&A session. So who would like to have a go at answering that question? David, it sounds like a question for you, I think.
Okay, well,
I can add something towards the end. So yeah, David.
And I think Uditanshu has already begun to lay that out. But you know, for all of these things, you know, the roadmap starts with really understanding what the cost and the size of the opportunity is, and that's where we're talking about the data mission. One of the real challenges that we found in our work in Tamil Nadu in India is that we do not have the readily available comprehensive sets that are looking you know, of data that tell us what is the hourly marginal price at each node, what is the you know, the amount of industrial consumption load pattern, so end use load pattern. What is the load pattern by air conditioning in different places, by agricultural feeding? So all of that data is the first step to really begin to understand this. This is the sort of thing that is being done in the United States, for instance, by the Electric Power Research Institute and others. Once you then understand that more, and all this can go in parallel, you also have to be doing the beta testing, which is because to get demand side management in place, you also need to get the right metering, the right types of incentives, to get the awareness from the commercial incentives, all the things that Uditanshu was talking about. So to start that, you need to do some pilot tests. So, you know, we're developing the data on one hand, but we're also needing to understand how we're going to make this work in an Indian context operationally, both in terms of the data collection, of, you know, the metering, the determining when there has actually been reduction. Should we be doing this through maximum capacity utilization at one time versus other? There's a lot of different mechanisms for demand management that have been used in different countries that we can apply. So once you have that, now you've got the data, now you've got the processes around each one of these commercial opportunities. We go to the final step that Uditanshu raised, which is around having the market signals that price allow the different demand and storage and power plant flexibility options to compete each other so that we can maximize efficiency. And that's where we get to the overall design of the market that has a combination of capacity that, you know, if you think about demand side management, for instance, for reserves, one of it is you have to be sure that that exists. So that's a reserve, sort of a capacity payment, a reserve payment. You know, you give me 1 megawatt of demand capacity, demand reduction capacity that I can call on X number of times over a season. So that's one thing. You need a capacity payment, and then you need a operation payment, that is for when you actually call on it. What's the energy price, and what are we going to pay? And those payments need to be set off in a market that compares them against the actual cost of the system. And that can only be done when we begin to have better pricing. That last step is something we're looking to happen towards the end of this decade, towards 2030. But we need to be building that up so that it will be there when we have it. But we need to have, in the first place, the data and the beta testing so that we can develop these technologies and options over the next few years.
I think I'll just add a couple of sentences to what David has very nicely defined already. And I think in terms of, Yashraj, I also saw your correction to the best of your knowledge. And I would say to the best of our knowledge as well, India currently doesn't have a demand response incentive mechanism, nothing explicit at least. And so what we have started to do first with India and then with the Tamil Nadu case study is kind of getting it down to more granular steps that the utility can take, because there is a lot of, both in storage as well as demand response, we believe that there is a lot of learning by doing. So you have to start doing some of these steps before, and you have to start procuring some of that capacity before you can set out to launch an incentive mechanism, or you can set out to launch the perfect market where this capacity could be traded. And so some of the immediate steps that could be taken, which is direct procurement, say for Tamil Nadu under the industrial demand, or looking at what can be done or can't be done with the agricultural capacity in the state. All of those, we believe, are some of the initial concrete steps that can be taken in that direction. In terms of the monetary term gains for customers versus generators versus discoms, I think what we have done is we have looked at the system cost impact of demand side flexibility, taking some very high level assumptions and some very concrete assumptions, depending on how much data is available. But how that then gets distributed, the value advantage that looking at demand flexibility would offer to the system, how that then gets distributed across consumers, generators, discoms, is something which would be entirely dependent on the business model. And that business model itself will evolve from whether you're talking about direct contracts where you need to provide a different distribution, to when there is a full-fledged trading market where, again, who gets to share more of the cream will change. So we have gone as far as understanding what the benefit to the system is, considering the assumptions, but the business model will decide how it gets distributed.
Great, thank you. Shall we move to the next question in the Q&A box from Narendra Kumar Manja? How practical is integration of captive diesel generation considering its high cost? I know that we've looked at the role of diesel generation, captive diesel in the work, so perhaps it's worth giving some context for how we view that in our work as well. Who would like to answer that question?
Yeah, I'm kind of raising my hand unless anybody else is, I guess. So for diesel generation, Narendra, I actually am going to just skip back to the slide where we have it very quickly so I can show the context. Sorry. Yeah, so you're right. It is a very expensive resource. Especially if we looked at the 2017 or similar curves arose at the 2018 peak balancing supply curve as well, where we've looked at, okay, what is the maximum capacity we think a particular resource can get? That's what's on the x-axis. And what is the price of being able to tap into this resource for flexibility? That's what's on the x-axis for this particular kind of flexibility. And as you'd see, that black box is way out away from the dotted line on the right-hand side of it on the top graph. But by the time we get to 2030, we see that our flexibility needs, especially our peak flexibility needs, is more than 3 times. And or a maximum peak need is more than 3 times. And there, on certain days, captive diesel generation is a valid option. So we're not suggesting that we add any more of that capacity. In fact, for most parts, we would suggest that a lot of that backup capacity could be replaced by battery storage as it becomes more cost effective. But what we are suggesting is any capacity that is available could be tapped into to meet the last edges of the flexibility need in certain cases for the right prices. I hope that answers your question. Let us know if you have any follow-up on that.
Can I add a couple of things just
sure, please.
to that? You know, more generically, when we're looking at any flexibility need, or capacity option, you're always balancing um, the capital costs, and that capital and costs, but both, for instance, buying the gen set, but also getting the metering and connection equipment that allows you to manage this or to call on this capacity, when it is needed, versus the variable cost. And each of these will depend upon the flexibility options. We've shown peak versus daily balancing, but there's actually quite a lot of different flexibility needs. So there's a type of flexibility that you need that will come up 1 hour every month, the type that comes up 5 hours 5 days a week. Both of those will have different balances of capacity needs versus the variable costs. What we're saying is that in the case that where you already have some diesel gensets in place, the additional cost of that is getting the connection that enables you, the transformers and the metering and communication systems that allows that to hook back to the grid to be used in those extreme times where, the 1 hour or the 3 hours a month that you may need to bring the diesel gensets online. And what we are finding is that on the margin here, that by 2030, where there is already backup gensets in place, it can create value to the system. It can act as one of the options. And furthermore, if you go to the discussion that we had about battery storage, when you layer on multiple flexibility needs, the economics can improve. And so, clearly diesel gensets is not a panacea from what we have. It is expensive, but putting it in the portfolio of flexibility options that you have here will improve our ability to manage the various sources and maintain a quality power supply at a low efficient cost.
Great, thank you, David. So moving on to the questions in the chat, we have one from Balawant Joshi, and thank you very much for your kind remarks about the work. He asks, the concept of flexibility importers and exporters is innovative. How do you expect it to be implemented in India? I'm not sure which one of you want to answer that question.
David, you're happy if I take that? And
sure.
if you
I'll
if you have additional thoughts, you can supplement. So, Balwant, thanks so much for your question. And I think the important thing there is that some of it kind of happens on the electricity side at the moment in terms of banking arrangements between states or exchange-led contracts. And so what we are envisaging around flexibility import and export is a combination of those two structures again, which is one is where direct contracts could be made between flexibility importer and flexibility exporter states, where they are aware that certain chunky amounts of flexibility requirements arise during certain parts of the year. Or additionally, the markets would allow people to trade flexibility as well, rather than just electricity. So an ancillary services market where you're allowed to trade some of your spare capacity at the extreme end, but an actual flexibility market that allows flexibility importers and exporters to trade that in real time. David, do you want to add anything to that?
Yeah, no, I think by and large that is what I would say. I think that one of the things we should not, we should not get mistaken is to think that flexibility is something outside of overall electricity market design. Flexibility is one of the key components about how we are designing electricity markets, both at a state level and at an India-wide level. And to the extent that we need to put in additional markets that complement what would be either a locational marginal pricing model, capacity markets, or ancillary service markets, it will be there may be some additional ancillary services that feed in here, but this is all part and parcel of improving an India-wide and state-level electricity markets to improve the efficiency of the electricity system. So as you improve the electricity system with better pricing and more locational pricing, a lot of the flexibility needs will begin to be addressed. And then you just have to feed back into that the special needs, as well as the parts of the market that you need to develop on contract to make sure that these technologies and options develop over time.
Thank you, David. And to a technical question from Ranjan Matal. What is the trajectory for coal and gas PLFs observed? And I think we'll ask Himanshu to answer that question, if that's okay.
Thanks, Ranjan, for the question. So for our analysis, both for India as well as for Tamil Nadu, what we have observed that for the PLF for coal is mostly for all the state GENCOs. It is mostly around 65 to 70%. And in case of gas, it can go as low as 30 to 35% as well. For all the NTPC plant, the technical minimum also is going till 55%. But in our analysis, what we have done is, in case of the thermal flexibility for the power plant, the thermal power plants, what we have tried to estimate is the incremental cost in case the plant actually goes from 55% to 40%. And then that incremental cost is coming from your increase in the net heat rate, your excess oil consumption because of it, and then the O&M cost increase and all. So that incremental change is also taken into consideration when we are saying about how exactly is the power plant flexibility is increasing the cost. So that is the overall trend which we have observed all pan-India as well as for Tamil Nadu plants. Yeah.
Thank you, Himanshu. And I think again from Ranjan, we also have another question. Are these cost savings with escalation included? I don't know, again, if Himanshu, you want to answer that question?
Most of the part of the cost savings we have considered the escalations, required escalation till 2030. Even when it comes to the cost for the coal and the cost of the power plants and all, we have considered the quite escalations from 2018 till 2030.
Great, thank you. And we have a question here again on demand flexibility with demand side response from Vibhuti Garg. And then we have another question as well from a follow-up question from Yasraj Kaitan. So we'll deal with those two questions. And I think unless anyone else has any burning questions, please add them to the Q&A box or even the chat. Or if you want to follow up with us offline, our contact details are there for Udsanshi and Himanshu. So Vibhuti asks, what kind of market design changes are required for consumers to provide demand side response? So again, another demand flexibility question.
Felicity, I will break the queue here and I'll just address Yashraj's question first, just because
fine.
It's a simple
It's a big
answer.
question. Oh, is it? Okay, I thought it was going to be a big answer. That's why I thought I'd finish on a flourish.
Question is a slightly more expanded answer. So actually, Yashraj, we haven't done a compare. I'm guessing what you're asking is if there a comparative analysis that has been done between demand shifting cost for industry versus open access, where we would potentially look at what is the advantage to the industry versus what is the cost to the industry of doing it either way. And we have not done that comparative analysis. So we most of our work on the industrial flexibility side has been focused on expanding the boundaries of what we can achieve out of that. And again, open access is very market oriented. So there is also the consideration that that is a moving target as well. And especially when you look at the 2030 timeline, any projections made on what the open access pricing could be could end up to be quite incorrect, which is one of the reasons also why when we were looking at Tamil Nadu, we considered for most of our analysis, we considered it as a self-contained unit without any exchange trading before we looked at, okay, what are the advantages that exchange trading then opens up, etc., which again becomes subject to whatever market price assumptions we then put on top of that. So the short answer to your question is no, a comparative analysis there hasn't been done. But
Can I add another thing?
Sure.
One of the issues about flexibility and that you need to be thinking about in terms of market design is that as a system planner, it's not just good for someone to respond to short-term hourly market signals at the time. You have to be confident that that reduction is going to take place. That is that when we start talking, as I said, the capacity or the availability requirements are also important. And so when you're talking about seasonal flexibility, for instance, that cannot be done entirely through hourly prices, because what will happen is you will end up at the point when it does occur that if people have not planned in advance to have that capacity shifted, they haven't made the investments, and then therefore they cannot respond. The price would actually go up to infinity. Yet, if you have a contracting market that puts forward a yearly plan that says, oh yeah, I'm going to make the investments and have this available and callable, the system operator can then schedule that in and then pull that when that event happens, right? So we have to be looking at the difference between the hourly markets and longer term markets for many of these flexibility options, the capacity to have that. Sorry, and I'll turn it back then to Uditanshu.
Thanks, David. So I think we have Vibhuti's question left, right? So what kind of market design changes are required for consumer to provide demand side response? I think that's a very that's a very expansive question, but I think what might be useful to consider is the first question to consider is what kind of consumer are we talking about? Because market demand response, is made up of a lot of smaller segments. The ones that we have considered for analysis for India and further on for Tamil Nadu are, we have looked at space cooling across the commercial space as well as the domestic and retail space. We have looked at what kind of opportunities we might have, what kind of potential we might have across industry. Again, industry has a lot of subsectors with regards to what kind of, each of the subsectors will have their own decision-making process and will have their own influences with regards to how much of their processes are flexible and what can or can't participate and at what cost. We have agriculture. So how much of the agricultural load, identifiable agriculture pumping load, is present on the grid, and whether that can be segregated from overall rural demand, whether that can be hence shifted from one part of the day to the other. Agriculture demand, again, is zero, it doesn't pay very much or pays minimal price. So considerations there, again, with regards to if you are spending the money to shift that demand, does that happen through solar pumps? Does that happen through feeder separation? Or do you take another route through incentives? So then you have EV charging, where again, what kind of EV chargers come into place? What kind of vehicles start the EV revolution in India? And so how can you tap into them? The business models will be quite decided by that. And I'm pretty sure I am forgetting at least one or two things right now. But so the reason for going through a lot of these components that make up demand side flexibility is for each of these consumer groups, what will make it attractive for them to participate in any kind of response would be very different. It could be price elasticity, but it could also be whether there is enough volume for them to be interested in, whether it is easy enough to participate, or is it possible for the utility to access control over the systems to be able to gather enough volume from a particular customer category for the necessary time period. Again, depends on which flexibility we are targeting. So I think demand response, the key thing to remember is each of the categories of consumers will have a different set of incentives, business models, and this is where kind of the importance of data also becomes very, very significant to, one, understand what is the landscape of the consumers in each of the particular categories, to understand what is the distribution of their utilization, what is the distribution of their demand profiles itself across different times of day, across different days of the year, and then tapping further into how their consumption pattern has changed as, again, trying it with different incentive structures. So with the larger players such as the industrial players, or where you have EV charging setups owned commercially, you could be contracting directly with the larger players to understand, okay, what is their price point? What is their pain point in terms of what they are able to accept, and at what cost, at what inconvenience, and how much they need to be compensated for. So understanding that through contracts for the larger players. For the smaller players, further changes will probably need to be brought into the market, like opening up the market to more competitive system suppliers, and also looking at aggregators, which can look at bringing together small demands, say packaging it in service proposals to bring the most appropriate service outputs and the most appropriate outputs to the smaller retail consumers, but also bringing in more aggregated, larger volumes of demand when it comes to the utility itself. So it doesn't have to deal with individually each of those consumers to meet its flexibility needs on a point-by-point basis. So I think in terms of market design changes, the immediate targets would be what we would target as the low-hanging targets. And here, I'm going to take advantage of the fact that we have done some thinking around this in Tamil Nadu, where we could be looking at pilot programs, looking at, can we do feeder separation for agriculture? Can we do contracts versus incentive structure testing for industrials? Can we just put some contracts in place for daily load shifting, for commercial cooling load, for large commercial buildings? And how do we raise awareness through some of these larger consumers before we go on to the more retail consumers? So there is an element of what's easy to access and hence set the parameters around before we move on to the more difficult segments of demand, I guess. I hope that answers your question, but please let us know if you have any follow-ups. Or David, do you want to add something to that?
No, I'm fine.
Great. So shall we wrap up there?
Sorry, yes, it was a very elaborate answer.
Okay. Okay. Well, that just leaves us to say thank you very much for joining us today. And we will, of course, be making the full report available, and we'll send that out later today. And of course, if you would like to watch again, the webinar recording will also be available, and feel free, obviously, to circulate that amongst your colleagues if they are also interested. So yeah, thank you very much for your time today, and have a good afternoon and evening. Many thanks.
Thank you very much.
Thank you very much.
Thank you.